Okay, so first we need to start from scratch. This is the syllabus objective. Perform operations involving surds, addition, subtraction, multiplication, and rationalization of the denominators of surds. So this is our aim. If you could do all of this, you're good to go, right? And that's what this PowerPoint is on. It'll be able to answer all of these things. Starting with the basics. What exactly is a surd? So a surd, let me go. All right. A surd is an irrational number. So you probably did this in math class already, but just in case you don't remember, an irrational number is a number that cannot be written as a simple fraction. So you see this here, this whole long decimal. If you punch into your calculator the square root of 5, you'll get this whole long decimal here. You're not going to get a fraction. So you know how some decimals, let me show you, like 3.3333333, recurring. This could be written as a third, right? So that's an example of one of these long decimals that can be written as a simple fraction. But surds, which is an irrational number, cannot be written as a simple fraction. So you see this whole decimal here, this long decimal, unlike 0.3333333, this cannot be written as a simple fraction. And that's why we call it an irrational number. So just remember that irrational numbers cannot be written as simple fractions. Okay, so back to surds. So we know that it's an irrational number, and it's also the square root of a number that is not a perfect square. What is a perfect square? We know that a number, so say I have 2 times itself, whatever this product is, this is called a square number. I mean a perfect square. Same with if I had 5 times 5 is equal to 25. I'll say that 25 is a perfect square. Why is it called a perfect square? Say I had, so let me just use dots for 5. And if I just continue doing this, right? For 5, I have, hold on. Probably did this in my class, I'll just make it. So I have 5 going across here, and I need to make sure I have 5 coming down here. 5 and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So see, I have 5 dots coming across. 1, 2, 3, 4, 5. So I have 5 different columns, and I have 5 rows. 1, 2, 3, 4, 5. And if you add up all these dots, 5, 10, 15, 20, 25, 25 dots in total. Why is it called a perfect square? Because these dots right here, they make a square, where this side is 5 and this side is 5. So this side would also be 5, and then this side would also be 5. So that's not something that you would see on the exam. That's just to help with your understanding of what a perfect square is. But you probably meet that term already. Just making sure that we cool on what the perfect square is. All right. If you have any questions, let me know. Right. So a perfect square is an irrational number, so it can be written as a simple fraction. And it's also the square root of a number that is not a perfect square. So I have some examples here. The square root of 5. We said that's 2.23606797775. If you punch that into a calculator, that's the long decimal you're going to get, right? This cannot be written as a simple fraction. And you see 5? 5 is not a perfect square. Same thing with this other example, 3. If I punch in the square root of 3 in my calculator, I'm going to get 1.732. This whole long decimal, which cannot be written as a simple fraction. And we know that 3 is not a perfect square. So that's why this is called a surd. However, if I said the square root of 25, we know that the square root of 25 is a perfect square, because if I said 5 times 5, that's 25. So 25 is a perfect square. And if I said the square root of 9, that's 3 times 3 gives me 9. 9 is a perfect square. So these are not surds because 25 and 9 are perfect squares. And if you wanted to write 5 and 3 as simple fractions, I could say, for 5, I could say 5 on 1 gives me 5, or I could say 10 divided by 2 gives me 5, etc., etc., etc. So it could be written as a simple fraction. That's why the square root of 25, square root of 9, those are not surds. Everybody following so far?
Yes, miss.
Okay. Let me know if you have any questions, yeah? So that was like the basics. You probably learned all that already. That's just a recap. So simplifying surds. A surd in its simplest form is written as k, the square root of a, where k is the coefficient of a surd. So it's any constant. It could be 1, it could be 3, it could be 7, -7. K is the coefficient of the surd. And a is called the radical, right? Let me circle this. This is a. A is the number that's under the square root. So this is my square root symbol here, and a is the number that's under the square root. Remember, we said a surd is the square root of a number that is not a perfect square. So what does that mean? That means that a is just the number which is not a perfect square. So referring back to these examples, square root of 5, my value of a in this case would just be 5. So a is any number that comes under the square root sign, the square root symbol, right? So you're not going to get tested on that in any past paper. That's just for your understanding, right? So just familiarize yourself with these terms. It's not like you're going to get tested on that. They're going to ask you, what is a? And no, they're not going to ask you that, right? So operations of surds. Surds can be added, subtracted, multiplied, and divided. And these are the rules you'll follow when doing these operations. So we'll go into this, we'll go into detail just now. But these are the 5 you need to know, right? So let me continue and go through them. When adding and subtracting surds, these are the 2 you would be using. This one, a square root of b plus c square root of b would give me a plus c square root of b. I'm going to explain that just now, right? Don't get worried. So this is what we're using, and we would also use this one. A the square root of b minus c the square root of b would give me a minus c square root of b. Don't worry, I'm going to do that just now. It's very important for you to know that only like surds can be added and subtracted. Okay, let me show you now. If they give me this expression, 2x plus 2, we know, basic algebra, 2x plus 2, we cannot simplify this any further. Why? Because I cannot add 2x and 2. But I could add 2x plus 2x. We know that this would give me 4x. So in algebra, these would be called like terms. Why? Because the both of them have x right there, right? The both of them have x. So these are called like terms. And I could add them if I wanted to. I could subtract them as well. But you see, good afternoon. But you see 2x and 2, these are not like terms. So I cannot simplify this any further. The answer would just be 2x plus 2. Everybody cool with that?
Yes, miss.
Okay. That's just algebra there, right? to help you understand what I'm going to say now. Right, so just like algebra, only like surds can be added and subtracted. So in algebra, only like terms could be added and subtracted. It's the same thing for surds. Only like surds could be added and subtracted. But what are like surds? Like surds have the same radical. Just going back to this slide. No, next slide. We said that the radical is A. A is the number we find under the square root symbol. So whatever number is under the square root symbol, that's my value of A. So say I have the square root of 5, the number that comes under the square root symbol, that is A, which is also known as radical. So what they're telling me here, they said that like surds have the same radical. So you see A, the value of A, which is the number that's under the square root symbol. Once they're the same number, that means that those surds are like surds. So I see 5 under here, and I also see 5 here. These are like surds. So I could add them, or I could subtract them. Look in here now, the numbers under the square root symbol, I have a 7 under here, okay? And I also have 7 under here. What does that mean? These are like surds, and I could add them or subtract them if I need to, right? So simplify the following. I give you 2, the square root of 5, plus 7, square root of 5. Hold on, let me just clear this whole thing. Looking at the rule here, it says that A squared B plus C squared B is equal to A plus C squared B. So now the question is, how exactly did they get that? If I wanted to factorize, right, I could say, okay, A squared B, C squared B, both of them have square root B in common. So if you're factorizing, like say you're factorizing a quadratic and you had 3x squared minus 3 is equal to 0, and I wanted to factorize this, I would say, okay, 3x squared and 3, both of them have 3 in common. I could take out the 3 and remain with x squared minus 1 is equal to 0. Same concept here. Just like we would factor out the 3 if we were solving by factorization, we would take out square root b because both terms have them in common. So I could take out the square root b. If I take out square root b here, what I remain with is a. So I'll put a here. They're still adding, so I put back the addition sign. And if I take out square root b, what I remain with? I remain with c. But this square root b times a plus c could also be written as a plus c square root b, which is what they have here. Everybody good with that?
Yes, miss.
No. I was just proving to you how they got that, how they got this formula. So you don't just memorize something and say, oh, well, that's what I have to do. No, understand how they came about with this thing. All right, so that's the rule we're following. Square root of a square root b plus c square root b is equal to a plus c square root b. So looking at my first example, hold on, I have 2 square root 5 plus 7 square root 5. We already said the value of a, which is the radicand, the values are both 5. So I was like, okay, these are like surds, and they can be added or subtracted. In this case, they want me to add them. So now that we know these surds can be added, we follow the rule. What do I have in common? I have square root 5 in common, so I could take that out. And what I remain with? I remain with the 2 plus 7. So I'll put that in my brackets according to this rule. And then square root 5 would be on the outside. But we don't just leave it like this. Why? It could be simplified further. We know that 2 plus 7, that's 9. And that's why the final answer is 9 square root 5. Everybody good with that? Yes.
Yes, miss.
Yes, miss.
Okay. Same thing down here. In this case, they wanted me not to add them. They wanted me to subtract them. But it's the same thing we're doing, same concept. I have the square root of 7. Square root of 7, I have them in common. So I could take that out. And what I remain with? 12 minus 5. But this can be simplified further. We know that 12 minus 5 is 7. So the final answer is 7 square root of 7. Okay, let's practice this now. Remember, if you have any questions at all, please let me know. So just follow this and you're good to go. Okay, so you could try all of these. I'll wait for you to finish all of them. I'll give you some time. If you want to, you could just send me an answer on okay. If you want to, you could send me an answer privately, or you could send it in the chat to everybody. Or if you want me to actually see it working to make sure that everything good, you could send me a picture on WhatsApp. So if you just want me to know your answer, send me on Zoom. If you want me to see your whole working, send me WhatsApp. So I could let you know if you went wrong anywhere, etc., etc. Okay, so try these 3 and then send me. This is what they gave us. Root 2 plus 6 root 2 minus 4 root 2. So these are the formulas that I told you about, the ones we would use whenever adding or subtracting sids. So it's A root B plus C root B is equal to A plus C root B. You said that's one of them. That's when you add in. And when you subtracting, hold on. Let me just reply to somebody. All right, so this is when we add in sids, like sids. When we subtracting them, A root B minus C root B is equal to A minus C root B. And remember, when adding and subtracting, we could only add and subtract like sids. Okay, now we need to look at our question. So there are 2 ways we could do this. First way, follow these rules exactly. So A root B plus C root B would give me this. So I see I have this first, so that's what I would do. According to this rule, this would become 5 plus 6 root 2. Why is it like this? Because I could factor out the square root of 2 because both of them have it in common. And what I remain with is 5 plus 6. Okay, so I have that minus 4 root 2. I could simplify this further. 5 plus 6, that's 11. And 11 root 2 minus 4 root 2. But we're not done. This could be simplified further. According to this rule down here, when subtracting like sids, this would become 11 minus 4 root 2. this could be simplified even further because 11 minus 4 is 7. And you put back root 2. And that's why this right here is my final answer. Everybody good with that?
Yes, Miss.
Yes, Miss.
Yes, Miss.
Okay, so I'll send you there 2 ways to do it. You could have taken it step by step. So do addition first and then do the subtraction, just like this. Or once you're comfortable with this topic, you could do it. Nobody's gonna stop you. Or I could say, all right, all of these terms, the 5 root 2, 6 root 2, and 4 root 2, all of them have the square root of 2 in common. So it's like, okay, I could take out the square root of 2 because all of them have it in common. And what would I remain with? 5 plus 6 minus 4. 5 plus 6 is 11, and 11 minus 4 is 7. So you get the same answer, 7 root 2. So, same thing. When you get more comfortable with the topic, you could do this, or you could do this right away. Nobody's stopping you. So take it step by step, or do this. Next question. If you have any questions, please let me know. Okay. Next question gave me 6 root 5 plus root 5 minus 3 root 5. Can anybody tell me what they got for this answer?
4 root 5.
4 root 5. Okay, now let's see if that's correct. So let me do the short way. The longer way, since we just started the topic. So when we add in both of them, we see that root 5 and root 5, they have that in common, so I could take that out. And what I would remain with is 6 plus 1. The 1 is understood in front here. Root 5 minus 3 root 5. That's 7. 6 plus 1 is 7, root 5 minus 3 root 5. But we're not done. They have like sides, root 5 and root 5. So what could I do? I could take it out. I would say, okay, 7 minus 3, take out the root 5. And we know that 7 minus 3 is 4. 4 root 5, and that is why that answer is correct. Everybody good, right?
Yes, Miss.
Yes, Miss. Yes, Miss.
Okay, last question. Remember, you could have done it the other way too, when you just add and subtract all the values at once, right? So last one, 4 root 3 minus 5 root 7. Can anybody tell me what they got for this answer? Crickets. Anybody? Miss Rose, you
Miss,
answer the
wouldn't,
question. Wait, repeat.
wouldn't it be the same thing since we can't do anything with it?
Yes, good job. These are not like surds. We said like surds have the same radicand. So this is the simplest form of a surd. And we said that the radicand is the number that's under the square root symbol. This is called radicand. We also said that when adding and subtracting surds, we could only do that if they are like surds. And we said that like surds have the same radicand. I'll just put rad, right? The radicand is the number under the square root symbol. For this, it's 3, but for this one, it's 7. these are not the same numbers. So these are not like surds. Therefore, I cannot add or subtract these. And that's why the answer would just remain 4 root 3 minus 5 root 7. Anybody good with that? Yes, no?
Yes, miss.
Okay, so the answer for number 4. What was number 4? Oh, this one was 4 root 5. Right. Let me see the thing. It was 4 root 5. Okay. So everybody good with addition and subtraction of surds, right? Because we finished with that.
Wait, miss. So no answer for number 5, miss.
The answer is the same thing.
Miss, so right about that, miss.
I have no idea what you just said. Can you repeat, please? Okay, hold on.
Miss, I was
Mhm.
asked. Oh, so no answer is there. So leave that out, miss.
This is the answer. The question is the answer. So if I was given this and they told me to simplify, I'll say you cannot simplify, and the answer is this.
This. Yeah.
You're good now, right?
Yes, miss. I was asking if you write about the same thing, miss. That's what I asked, miss. So you're right, miss. Yes, miss.
You could write back the same thing, or you could say cannot be simplified. Something like that, to show that this would be the answer, or it cannot be simplified any further. Okay.
Yes.
Oh yeah, I have a little over 2 minutes. So somebody has asked me how I got 4 root 5 for this. Okay, this is what they gave me. According to the rule, gosh, would I be able to finish this in time? Let's see. This is the rule. C root B is equal to C plus A root B, and A root B minus C root B would give me A minus C root B. Okay. If we're looking at these two first, you'll use this rule when we add in them. Okay, so according to this rule, this would become 6 plus, the 1 is understood, so I'll put 1, and I take another root 5. Because 6 root 5 and root 5, they have root 5 in common. So I take that out. That's what I remain with 3 root 5. 6 plus 1 is 7 root 5 minus 3 root 5. I think that's where your problem, that's where you went wrong. Because you asked me 6 minus 3, but it's 6 plus 1 minus 3. You understand that? It's 6 plus 1. The 1 is understood. You can't just leave out the 1 and put 6. It's 6 plus 1, which is 7. Okay, we need to leave and rejoin because they're going to cut off. Okay, let me just end it. Rejoin.